Getting in progress.
Hello. Yeah, Ashish, this is Rajesh Prabhakar. This payment will be processed at the end of the semester or will you initiate now? Okay. So I can expect in January. Mm-hmm. Okay. Okay. Yeah. Yeah. That's what. Yeah. Okay. Right. Sort also is dot NA HR train comma decreasing is equal to true. Okay, you have to add one more comment there. NA dot strings is equal to C of while importing, you have to add the NA function also because education it is not recognizing the missing values. Similarly, sort Colson's is dot na HR test decreasing is equal to 2. Yeah, control enter. Which one? No, you check there might be red button here down. It's still working. Close that. Stop that. NA, not no. NA dot strings. It's A. Because the education also had missing values, no? It was not showing. So this NA dot strings NA has to be added when you don't see missing values in some variables. Always add it, that would be a better option to be on safe side. What happens is if the column has special characters and all, it don't identify it. This is up apostrophe S is there, bachelor's, that's why it is causing problem. Okay. Huh? Yeah, same. Combine data frame for pre-processing. So combine DF is equal to R bind, row bind. We call it as row binding, which is equal to concatenation. HR train square bracket minus the last variable is promoted 14 comma HR test, because for row binding same rule, number of variables must be same, sequencing of the variables also must be same. So we have a combined data frame of 13 variables. Dependent variable not there. We have kept it separately. So minus 14 means it will ignore it. It will not delete it. It will ignore it, and rest of the variables will be taken into consideration. So table combined DF dollar education. Use NA is equal to always. So 3,443 are missing values. Combined DF dollar education is equal to if else is dot NA combined DF dollar education. If the condition is met, comma, double quotes, bachelors. Else combined DF dollar education. So retain the value if it is not a missing value. If it is a missing value, it will use if statement, value if true. Logical test is dot NA combined DF dollar education. The logical test is this. Is dot NA, true or false. If it is true, it will replace it with bachelors. If it is false, it will take the value whatever is there in the cell. So if I run the previous command again, now you can see NA is 0. So here also we will use 3 as the average rating. Okay. So missing value treatment we have done where we combined the data frame and we found out. So first we have treated the missing values in the education, and then we have treated the missing values in previous year rating. So using the if else statement where we given a logical test, if the value is true, the replacement, and then otherwise retain the same value. So this is how we do the missing value imputations. Call names combined DF. Call names combined DF. We have to identify the character columns and we have to convert them to factors. Convert them to factors or dummy encode. So 2, 3, 4, 5, 6, 9, 11, 12, 2, 3, 4, 5, 6. 2 colon 6, comma 9, comma 11 and 12 is equal to L apply comma as dot factor. So STR combine DF. So we have converted those character variables to dummy encodes. You can see here numerical identifiers have been assigned. In R, we call it as factorization, factors. Whereas in Python, we call it as either label encode or get dummies. Here it is factor. As dot factor will convert it. So department has 9 levels, analytics, finance, and it has assigned the numerical identifier. Similarly, education has 3 levels: bachelor's, below secondary, master's. And it has assigned the corresponding numerical identifier for each of these categories. What happened? Which one? Education. Education has only 3 levels, no? Bachelor's you have to give correctly. Single quote and copy paste the bachelor's. Re-import the data and do it again. It will corrupt. You have to re-import the data. No. Category change, name changing is different. Levels change is different. Column name you can do it, but level changing, you have to write the levels command again. Rather correct the error, go to the top and re-import. Okay. Split data into train and test. HR train underscore df is equal to combined df square bracket 1 colon 54808. Oh, sorry, I forgot comma. HR test underscore df is equal to combined df square bracket 54809 colon 78 to 98 comma. Hello? Yeah, tell me. Yeah, it's okay. And also, okay, Tuesday and Thursday are blocked, right? Okay, okay, okay. Okay, right, right, yeah. Which one? Uh, no, no, I didn't get you. Oh, uh, different, yes, yes. For prediction unit, this is HRN. I think I have used another data file, analytics file, different one might have used, not this one. This is a analytics with the file, so we need test data also, right? For uploading the predictions into the website. So you have to build a model on trained data, predict on test data, and you do the sample submission onto the competition site, right? For checking the accuracy of how accurate your model is. Yes, train as a dependent variable, test does not have a dependent variable. You have to predict the test dependent variable using the train model. Then we copy the predictions into sample submission file, and then we will upload it into competition site. So HR train df is equal to data dot frame HR train underscore df comma is underscore promoted is equal to HR train dollar is underscore promoted. So we are adding the dependent variable back to the train data frame. We are adding the dependent variable back to the train data frame, which is cleaned now. Okay. So our dependent variable promoted are 4668, who are not promoted are 50,140. 0 means not promoted, 1 means promoted. So summary, HR train underscore DF. So once you convert the factors, you will get for is underscore promoted also has to be converted to factor. So HR train DF dollar is underscore promoter is equal to S dot factor HR train underscore DF is underscore promoted. Now, once you have converted the factors and all, see for numerical data, it is giving you descriptive statistics. For non-numeric data, it is giving you frequency counts. For non-numeric data, it is giving you frequency counts. See, gender, female 161312, male 38496, bachelor's, below secondary and masters. So, once you convert the data to factors, when you run the summary command, for numeric data, it will give you descriptive statistics. For non-numeric data, it will give you frequency counts. For non-numeric data, but initially it will not give you. The data is in the character format. It will not give you this data. It will simply say character and length. And it will give you the descriptive statistics for only numeric variables. But once you convert them into factors or dummy encodes, then you run the summary command, you will get the frequency counts along with the descriptive statistics of the numerical data. Got it? Test null, the average training score of male and female employees equal. Test null, the average training score of male and female employees equal. So what we have to do first, we have to do the aggregate. Then we write the null and alternate. Then we run the test directly. And the inference is based on the p-value. Okay. What is the null? No significant difference. In average training score of male and female. All this significant difference. P dot test, which are trained, df dollar, average training score, tilde, which are trained, df dollar, gender. No, p value is less than 0.05. Reject, null. Very small difference is there, but still it is a big difference. See, 63.88 and 63.17. Test null, the average length underscore of underscore service of is underscore promoted 0 or 1 equal. Done? Reject or fail to reject? Okay. Rational, the average training score of different education equal. On our single factor. Department is there, right? Average length of service of different department equal. So reject null, right? Okay. That's null, no association between is underscore promoted and gender. No association between is underscore promoted and gender. Hmm? Object null. Right? Pearson's chi-square test with its continuity correction. Education and attrition. Sorry, promotion. Is underscore promoted. Education and is underscore promoted. Okay. So the dependent variable is underscore promoted is non-numeric and binary. Dependent variable is non-numeric and binary. So we have to use classification models. The primary model is binary logistic regression. Explains relationship between a binary non-numeric dependent variable and multiple independent variables. So binary logistic regression explains the linear relationship. Sorry, I forgot the word linear. Between a binary non-numeric dependent variable and multiple independent variables. P is equal to e to the power of beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 till beta n x n. Same equation downwards, 1 plus. This is the logistic regression equation, or in simple terms, also called as sigmoid, which is 1 divided by 1 plus e to the power of minus z. 1 by 1 plus e to the power of minus z. So P is the probability, E is the exponential, P1, P0 is intercept, B1, B2 till Bn coefficients, x1, x2 till xn independent variables. So binary logistic regression is what we have to build when your data is, when your dependent variable is non-numeric in nature. And it is binary, 2 levels, yes or no. Okay. So let us build the model. Logic is equal to GLM, generalized linear modeling, is underscore promoted tilde dot comma data is equal to HR train underscore DF square bracket -1 employee ID. We are deleting employee ID, comma family is equal to binomial. Family is equal to binomial. GLM, generalized linear modeling, is underscore promoted tilde dot. Tilde dot means include all variables as, all other variables as independent variables. Tilde dot means include all other variables as independent variables. And HR train DF -1 means we are ignoring the first column, which is the employee ID column. And family is equal to binomial, because GLM runs other regressions also. In generalized modeling, we can do Poisson regression. We can also do exponential regression. We can also do multinomial regressions. So we have to specify the family of regression which are doing, which is binary or binomial. Summary logic. To see the output, summary logic. So we will get the statistical output. The first one we have to check is AIC. Kaikus information criterion, lower the better, no fixed value. First one you have to check is AIC, Akaikos information criterion. There is no fixed value for this metric, but lower the value, the better. Project ఉంది కదా. It is the same problem on the question. And data అనేది. It's a comparative metric. So it's comparative. You have to compare one model AAC with other model AAC. On its own, it is of no use. It is a comparative metric. That means you have to build one more model and then you compare it. Otherwise, it's of no use. But like we have, it's a replacement for R square. AIC is replacement for R square. In regression, we look at R square, right? Adjusted R square. Similarly, here we have to look at your AIC. Yeah, score value, you get R square, yes. No. AIC is not, you will not get AIC in Python. It's a statistical metric. AIC is a statistical metric. You won't get it in Python. The formula of AIC is this. Minus 2 log likelihood plus K and number of parameters. So when we calculate log likelihood, like I showed you in Excel, right? Using solver and all I showed you. Log likelihood will be calculated, and based on log likelihood, it will calculate the AIC. So the first metric you have to look for is AIC. The second metric is null deviance and residual deviance. The difference between must be larger So the difference between the null deviance and residual deviance must be larger. Null deviance is deviance with intercept only and no independent variables. So what is null deviance? Null deviance is where your model will have only intercept. No independent variables will be there. Residual deviance is deviance calculated after addition of variables stepwise or one by one. By adding the variables stepwise or one by one, what is the change in the deviance? That is your residual deviance. This is the final residual deviance after adding all the variables to the model. This is the model with intercept only, without any variables included. This is the final deviance that is calculated after addition of all the variables. Now we can find out using ANOVA logit comma test is equal to chi-square. So if you see here, the null deviance is 54,807. sorry, 31,922. So the null deviance is 31,922. After the addition of the first variable department, the deviance reduced by 152 to 155. So the deviance came down to 31,767. After that, null plus department plus region, the deviance is 31,264. Null plus department plus region plus education, the deviance is 31,252. So by addition of each variable to the model, the deviance reduces. After addition of the final model, final variable average scroll, the final residual deviance is 21,373. Now, if a variable has significant deviance, then it is considered as significant. Deviance means change or impact. If the variable is causing significant amount of deviance, then only it is considered as significant. Take for example, previous year rating. Look at the amount of deviance it is causing. 1,414 points it is causing the deviance. So it is considered as significant variable. Now length of service 0.3. That's why it is considered as insignificant variable. You see here, there is no significance here. If I scroll up and see the output, here also you can see length of service, okay, interaction, it is becoming significant here. But because of interaction with other variables, it is becoming significant. Now regions, I think, is becoming insignificant, some of them. Departments, all are significant. Regions, some of them are significant. Number of trainings is significant. Age is significant. Previous year ratings are all significant. Length of service, awards won, average training score, they are all significant. See the p-values. So the third criteria is the one which we have in our regression. Independent variables p-value must be less than 0.05. The third condition is independent variables p-values must also be less than 0.05. If any variable is not having p-value less than 0.05, you can remove that variable and rebuild our model. We can remove the variable and rebuild our model. So the statistical output of this is this, of logistic regression is this. AIC, null deviance and residual deviance, and independent variables p-values. Now, but another metric is also very important, right? Which is based on confusion matrix. Based on confusion matrix, we have certain metrics that are also important, right? So the one, what is the first one? Accuracy, which is TP plus TN divided by TP plus FN plus FP plus TN. So this is, we need to calculate. In Python, what it will do, in the backend it will do, because it doesn't give you the statistic metrics, it only gives you the confusion matrix based accuracy. In R, we get the statistics metrics first. In R, we get the statistics metrics first, then we have to manually calculate the accuracy. Okay, so logit predict is equal to predict logit, the model name, comma, type is equal to response. Now type is equal to response will give you probabilities. Type is equal to response will give you probabilities. If I say logit predict, see, you get the probabilities. Table actual is equal to HR train DF dollar is promoted, comma, predicted is equal to logit predict greater than 0.50. We get the confusion matrix. Now, how do we calculate? 49,808 plus 1272 divided by 49,808 plus 332 plus 3396 plus 1272. 93.19 is the accuracy. Accuracy 93.19. Okay. Library caret. Minor differences will be there. If else, logic predict greater than equal to 0.50, comma 1, comma 0. Install caret. So go to packages, install CARET. Is a very important package, install CARET. Click on packages, click on install, and then caret. Oh, net is working, na? Airtel, na? No, no, not Airtel. Use Classroom 2.4 GHG. Airtel, I think it's not working. You need internet for downloading the library. Otherwise, it will create problem. Hmm. Which one? Yeah. Yes, you can do. GLM in Python, you have to install a library. Then you can do it. But what happens in Python is they don't take statistical methods, Poisson and all those things they don't take. That's the thing. Oh. No, it won't give you. It won't give you. Because SAS Python, the problem is there. Uh, uh, Rather, you can use PySpark. PySpark, Python Spark is there, na Apache Hadoop. So what in Capgemini they did was PJ 17 students, they converted SAS codes to PySpark code, and they built the model in the PySpark. So that worked well for them. They said it is performing well also. So base Python sometimes creates issue. They are using PySpark only. Because that is zero cost, na? So that is the advantage. So because of the no cost in Python Spark, they are using PySpark now. I think they have not finalized it as of now, but they were. Which one? Ongoing projects are there. Okay. SEB, SEB, acha, SEB, okay. What happened to the data? Where did I write it? 1 second. 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 1 sec Classification PG identity. Yeah. For data classification PG identity. HR trains CSC. You're talking about these generalized linear models, right? These generalized linear models in Python, some of them are there, some of them are not there. That is the problem. Response is promoted. Event of interest is one. Classification, department, region, education, gender, previous rating. Continuous variables, number of trainings, age, length of service, average training. Okay, so model is main effects model. Selection method. None. Options, default statistics. Diagnostics, parameters, exactness, goodness of food, classification table. Plots we can do. ROC plot. That's a special scoring only. Okay. It's imported carrot. Yeah. Okay. Ah, okay. AUC of 0.8772. So we got the so we get the same metrics in SAS also, but we get a lot of additional metrics compared to the base metrics. On-demand academics is free. On-demand academics is free. Anybody can do. Yeah, on-demand academics you can use. It is absolutely free of cost. If you say you're a trainer and you're looking for training, they give access to enterprise minor also. Enterprise minor, enterprise guide also. No, that's okay. It's not other. Loaded required, that's okay. That's not another. string one. So you have to install string one. Just install, click on install. You have to install or click on install string one. It's the one I'm using. Loading required is not error. It will give you clearly error. If it is error, it will point it as error. Loading required is not an error. Okay, got the output. Okay, you can take your break if you're done. That is to write the output. The cleaned file is there, no? I have written it as a CSV file. In the project folder, you will get the CSV file, the cleaned file. Because I wanted to import it into SAS, that's why I have written it as an output file. Write out says is output. Our HR trained DF is cleaned data, right? With missing value imputation, categorization, conversions and all. So I have written it as train.csv. It will store in the project folder. Site is not. No, library is standard. But see, it's something you have installed it, say that you install it in the install it. Install it. After that, character. మనం చార్జర్ మర్చిపోయాను. ఇంకా పెట్టుకున్నా ఏసీ బండి So tree-based models, single tree model, decision tree. It's both classification and regression model. The output is a tree from which rules are created and rules will be used for prediction. Rules will be used for prediction. Now, decision tree is binary splitting tree with recursive partitioning. Binary splitting tree with recursive partitioning. The splitting methods are Gini, which is 1 minus sum of probability of I square. Then you have entropy and information gain. Entropy sum of minus probability of I into log probability of I second case, comma 2. Information gain is entropy of dependent variable minus entropy of independent variable. So lowest Gini first split and ascending order till 0.40. Highest information gain first split and descending order till 0.50. So decision tree also provides variable importance as part of output. As part of output, we will get variable importance. The only disadvantage is overfitting. Overfitting, which is controlled using max depth of the tree. Okay. Okay. Now, there is an inbuilt library called RPAT. You don't need to install it. It's a inbuilt library RPAT. You have to install a library called rpat.plot. This is for plotting the tree. You have to install. Okay, your cycling is corrected. Library rpat.plot. Recursive partitioning trees. Tree is equal to rpat is underscore promoted tilde dot comma data is equal to HR train df square bracket -1. Summary tree. So it has built a very large tree with almost 267 nodes. Very large tree it has built in the back end. Okay. All of you got the output summary. Now the summary output, like in Python, will give you detailed explanation of every node in the tree. Every node in the tree is explained. In the summary output, you will get complete explanation of each and every node of the tree. We can get the same thing in Python also. This is one thing which matches in Python. In Python also, we get the similar type of output, export underscore text. We'll get the complete description of the tree. Same thing here. So if I say summary tree, you can see here the formula, the variable importance. You can see here variable importance. So average training score is important, department is important, KPIs met important, awards won, previous year rating. Rest of the variables are not important. And the first node split on average training score less than 90.5. The first split happened on average training score less than 90.5. 54,229 onto the left side, 579 observations onto the right side. Then these are sub parameters in the sub branches in the tree. The second major tree broke out of the 54,229, which is based on KPIs met, yes or no. 35,000 to one side, 18,000 to other side. So like that, each description, each component's description is given, and the probability of each node is given. So each node is explained in detail here. Okay, so this is a theoretical explanation of the nodes, which you can get if you want to print. It will come into pages and all, or else you can do the visualization. rpat.plot tree. So we got very small letters. Let us increase the CX is equal to 0.30. You can get some sort of clarity here. I think you will get a better plot because of the projector issue. I am not able to get the proper plot. In your screens, you will get a good plot. You can see the variables and the values on which it is splitting. Yeah. So see, one rule is like this. If I say rules, if average training score is less than 90.5, this is yes is if the average see if the average training score is less than 90.5, no, it is straightly going to the end point. You can see the line here. If it is not less than 90.5, less than, right, it will straightly go to 1. That means he'll be promoted. That means the rule is like this: less than 90.5, no, means what? It is greater than 90.5, right? Less than 90.5, yes, means what? His training score is less than 90.5. So employees who are scoring greater than 90.5 are outrightly promoted. 1. You can see here 1, right? You can see here 1, right? Directly. So if an employee's average training score is greater than 90.5, he will be promoted. If it is not, then he has to go to the second parameter. What is the second parameter? KPIs is met, yes or no. If his KPIs is no, he will not be promoted. 0. If he didn't meet his key performance indicators, it will be outrightly no promotion. You can see here the line is coming to 0. If he has met his KPI, is 80%, then it goes to the third parameter. What is the third parameter? Awards won, yes or no. If he has not won any awards, then it goes into another parameter. Average training score less than 70. And then it splits into 1 and 0. 1 is promoted, 0 is not promoted. Now you can see the rules here. rpart.rules. rpart.rules 3. The detailed rules are given for prediction. And in rpart.rules, you get 0. 0 is you get the probabilities here. The probability is 0 when his average training score is less than 60, when he has not met his KPIs, and when he has not won any awards, and his previous rating is 1, 2, 3, or 4. He will never get promoted. 0, 0, all these things are rules for not getting promoted. Who will get promoted? For these 3 rules are for the people. These are the rules for the people who are getting promoted. 67 probability if the average training score is between 59 to 91 and KPIs met is 0 and awards 1 is 1. Even if he didn't meet his KPIs but award has 1, then he will 67 probability that he will get promoted. 73 if the average training score is 64 to 91, KPIs is 0, awards 1 is 0, but his previous year rating is 5. And department is finance or HR or operations or salaries marketing, when average training score is 0.88, when it is 91. This is the first rule. The first rule which I told you, now, this is the first rule. 88 probability when the training score is greater than equal to 91. 88% probability that if his average training score is 91, he will get promoted. This is a single rule. The first rule which I showed you on the graph is this rule. Right? When the average training score is greater than 91. So you will get rules like this, and these rules are used to predict the probabilities. Based on the probabilities, again the rule will be implemented. Greater than equal to 0.501, less than 0.500. 0 means not promoted. 1 means promoted. So this is how the rules are created from the tree. You got right? The first rule is very simple. If greater than 91, he will be outrightly promoted. 88% probability. That is very high probability. He will automatically get promoted. So this is how the rules are created from the tree itself. And these rules are used for predictions. Got the understanding of the rules? So R part rules, we printed the rules. Now in Python also we have the function for printing the rules. In the next version, we are getting it full time. That code is being implemented already. We will also get the similar rules in Python also. Now these rules, if they'll compare each variable, whether it fits into which rule. According to that rule probability, it will be given the final probability. Based on the predicted probability, you will calculate the predicted class. Based on the predicted class, you will create the confusion matrix. When it is coming to this side, we have one is that one is based on considering all the other factors. All the factors. This is the larger, no? If you are looking at the largest rule, this is the one of the largest rules. These two are the largest rules. So, which rule will be considered? No, we have differential rules, na, here. The departments are different, right? Parameters are matching, but the different departments are different. So you will have some sort of difference in the rule. Some numbers will match, but there will be something which doesn't match. That marginal thing will change. Here we have finance, legal, and operations. Here we have HR, sales, and marketing. So if a person to be promoted in finance and legal, they will follow this. His average training score should be 60 to 91. KPIs is the thing, award is also, but his previous rating 1, 2, 3, or 4. So that's how it will go. See, for some departments, even though they don't win the KPI, see, finance, legal, and operations, what KPIs they will have? Very minimal, right? Compared to a sales and marketing person or client-facing person. These are back-end guys, right? Back-end guys will have limited KPIs. And awards also will be limited for them. Compared to the sales, you have a lot of awards given in sales teams, top performers. You get a lot of awards in finance teams, top performers, and all those things. Then your advertising guys, marketing, communications, all those things will get good awards. But the back end, like legal, back end guys, very few awards they get, right? They have very few KPIs. They are support guys. So they will have certain amount of less advantage in terms of getting promoted also. So their rules will be a little bit harsh. Probability. No. But rule is there, na? You remember the probability rule? Greater than 0.50 is equal to 1. 1 means what? Promoted, yes. So you have rules for promoting from here. And you also have rules for non-promotion. See, these are all probabilities less than 0.50. These are all rules for not getting promoted. This is the beauty of decision tree. It gives rules for both getting promoted and also for not getting promoted. So you have two sets of rules here. One for getting promoted, which type of employees have probability of getting promoted. These are probabilities. These numbers which you see at the beginning are probabilities, which are needed for classification. Greater than equal to 0.50, less than 0.50. Based on that, it will give. Because this is a classification problem. If you are using it for regression, you will get a predicted value here. You get a predicted value. I'll run the same thing on regression now. You'll get a predicted value. Like in regression, the equation creates a predicted value, right? Here also the rule will create a predicted value. That is how it will work. But before that, let us predict. R part predict is equal to predict tree, comma, type is equal to class. Here you can get both probability predictions as well as class predictions. In case of logistic regression, you only get probability predictions. Whereas in case of decision tree, you can directly get the class predictions. Table HR train here dollar is promoted, comma, R part predict. You have the confusion matrix. So 49,906 plus 1194 divided by 49,906 plus 234 plus 3474 plus 1194. 93.23. You get an accuracy of 93.23, slightly higher than logistic regression. One second. Confusion matrix as dot factor, which are trained here, dollar is promoted, comma, as dot factor are hard to predict. Comma positive is equal to 1. You get the same confusion matrix and you will get the same matrix. See, we will convert this as your biggest mean square error. These promoted have not converted it as factor. Mean square error is what? Mean square error is for regression. Mean square error is for regression. So you have to convert it into factor. Then only you will get the correct output. Here also, okay, here is taking no problem. But what is happening is you are getting mean square error. That means it is treating it as regression data. So here you have to add as dot factor. For each promoted, you have to tell the algorithm to treat it as factor, not as regression data. No, that is not regression. Regression doesn't have a class size. Now it was problem. Because we build a regression model, it can't predict a class. C small letter. That is equal to class here. C small letter. Got it? You also think of see, you're getting mean square error. Mean square error is regression, not as classification. So, as dot factor. That means you should not treat them as numbers, you should treat it as class levels. You know what problem is. Got it?
So, I mean, the calendar is working, but the cycle is coming.
Cycle is?
Not this one.
I think.
Just one thing.
What is the site? The version of this pattern for the version of our might be available elsewhere. See the idea is that the plant must be external installing from the packet is going from the shipping. What packet is suggesting to install? It should suggest not one packet to install. Site package. Which for install. See, the only thing is they're saying upgrade to the latest version. That is the problem. Version problem only is causing it. Did you uninstall the old version from your system? Control panel. No, old version. Did you uninstall it from control panel? Check your control panel. There will be some version available. Because it is not suggesting which package is not installing. If it suggests which package is not installing, then we can install that and reinstall the package. Control panel. Uninstall program. Uninstall a program. Go back. Uninstall a program. Sometimes what happens is it doesn't uninstall the previous version. What they want to do. When you have what instructions installed, it will get confused. Installing environment. Okay, done. So you try tomorrow. Will you want to try with the regression?
Yes, sir.
You have that last session's file. Bike data. So in bike data also, We have the data, I have all the data here, so no need of importing. Bike data DF. Library R part. Library R part dot plot. Last class, bike data. Bike R part is equal to R part CNT tilde dot comma data is equal to bike data DF. Summary bike R part. Now you can see here in regression you get mean square, MSC. So for bike data, the important variables are casual, ATEMP, month, season, year, working day, weekday are important variables. And you can see here, it is taking mean square error, not the probabilities. In case of classification, we get probabilities. Here we will get mean square error, see, MSC and mean. So for regression problems, mean squares error. For classification problems, probabilities. R part dot plot by R part. So you get the plot here. Causal less than 726. No. Yeah, what you call year 0. ATEM less than 42. 3%, 37%, 6833, 5011. The bike predicted values. The demand. R part dot rules. Bike R part. So these are the rules. Now here we get predicted values. See, count will be 1539 when causal is less than 122. When casual value is less than 122, the demand for bikes will be 1539. 1543 if casual is 122 to 304 and working day is 0. 2487 when casual is 304 to 726 and working day is 0. So you have different rules for different demands. Highest demand rule is this. 6833 when casual is greater than 726 and year is 1 and ATEMP is greater than equal to 0.42. Same rules on the tree is used for prediction. Bike R part predict is equal to predict bike R part comma type is equal to vector. Bike R part predict. So you get the predicted values for each observation using the rules. Now, SQRP mean bike data DF dollar $CNT minus bike R part predict the power of 2. So we get an RMSE of, this is RMSE, root mean square error. We get the RMSE as this value. 768 is the RMSE we get for the data. Root mean square error. The predicted values, you have repeated predicted values because the rules have same predictions, right? For this bike data, whether we can use this logistic regression model, whether it will be suitable for this prediction. Means because logistic regression is for binary data. It's like 1 or 0. But here the bike prediction is not this or not. Whether the regression model will be the correct choice. If you want to use classification model on this data, you have to create a variable demand. Let us say this is day wise bike rentals. So if today's demand is greater than previous day's demand, high or else low. You create a high-low column. That is again a binary dependent variable, right? Then you can take demand, high or low as the dependent variable, and then you can convert it into a classification model. So you have to change because data structure, variable data structure have to change. So CNT is there, right? CNT is numerical continuous. It has to be converted into what we call binary. So you have to add a column called, let us say, in this data, you have season, no, this is the complete data. We have day-wise data here, right? Sequential dates. So using the CNT at the end, you can create additional column. If today's demand is greater than yesterday's demand, high or else low. A simple if statement, and then it will create a variable called high-low. Then you delete the first row. Because first row we can't get any output, that will be NA. You omit the first row, and for the remaining columns you get high-low. So that will be a dependent variable. So you will convert it high-low into 0 and 1. Then you will predict. Then you can do a classification model. So if numerical models are not fitting, then we have to do that one. No, for this, what we have done is like. We can't treat it as a dependent variable. This is a regression problem itself. Regression works well on this data. So we don't have an issue. But sometimes some numerical continuous data regression doesn't work, particularly stock market data. Bitcoin pricing, stock market data, we have found out if you treat it as a classification data by adding a variable like, up, down, compared to yesterday, current day versus yesterday, whether today it is up or down, then you have a good results. For some asset classes, we have done that. Then what you can do, you can extract what day of the week it is, what month it is. From the date you extract variables, right? Then we use that things as independent variables, week, day, month, quarter. If you have hourly data also, morning, afternoon, evening, pre-break, morning, afternoon, three trading sessions. What you call, you can split the day. Early morning session, midday session, last session or end session. Then you can see which session is affecting the price. All those things can be done. So for some asset classes, we do that. So that option you have when your numerical data is not giving you a good model. Then you have to convert your numerical dependent into a classification, either binary or multinomial, based on the data type. Sometimes binary also doesn't work. You have to make it more than 2, high, medium, low. Then it becomes a multinomial logistic problem or multinomial decision tree problem. All other models exactly works. Multinomial works very well. Then also you can do that. But in stock market data, I have seen a couple of models where they converted the close price, which is numerical data, to up and downs, and then built a model which was giving more reliable predictions than building a regression model using the open, high, low, and the volumes and all those prices. We standard scale, and then we try to predict the close price. There we were not getting the better predictability. Not even when you use the high-end neural networks also, it was giving less probability. But once you convert it into classification and use create variables and do it, it was doing well. Up-down prediction is easy to do, na? Numerical prediction is a little bit complicated. Binary probabilities are easy to predict compared to a numerical continuous. Got it? Corrected, huh? Okay, I've sent you the file.